When we are working with a right triangle that has internal angles of 30 degrees, 60 degrees, and 90 degrees, we can take advantage of a special property that can help us find the lengths of one of those sides. But first, we have to remember that the three internal angles in any triangle always have to add up to a total of 180 degrees. That means in this triangle where we can see we have a 90-degree angle and a 60-degree angle that are given, we are able to do a simple calculation: 180 minus 90 minus 60, and that gives us 30. We know that the missing angle that was not given has to be 30 degrees. In this right triangle, we are given a 90 degree and a 30 degree. So doing the same calculation, 180 degrees, the total, minus 90 and minus 30, the angles that are given, must give us the measure of the missing angle, which is 60 degrees. This calculation also justifies that this angle here in this triangle must also be 60 degrees. This becomes very routine after doing it a couple of times. When you see a right triangle with a 90 and a 30, you know the missing measure must be a 60. And when you see a right triangle with a 90 and a 60, you know the missing measure must be a 30. The special property that affects only 30 degree, 60 degree, 90 degree right triangles is that in those triangles, the length of the hypotenuse is always equal to exactly double the length of the short side or the short leg. This is not the only property that affects 30, 60, 90 triangles, but it is the property that we are dealing with in this video. If the hypotenuse is equal to double the short side, then I can calculate the missing hypotenuse that is being asked for in this right triangle. The missing hypotenuse is my unknown. It's equal to 2 times the short side, which in this case is 4 centimeters. That means the hypotenuse must be equal to 2 times 4, which is 8. And because the unit of measure given in that triangle was centimeters, the hypotenuse is 8 centimeters in length. So we have a clever little trick, which is easy to use, that helps us find a missing hypotenuse, but only in a 30, 60, 90 triangle. In this example, we are given the hypotenuse, but we are being asked for the short side. The same property can be expressed in this way. The short side must be equal to the hypotenuse divided by 2. The short side must be equal to, in this case, 100 divided by 2. Therefore, the short side in this case is equal to 50. Because the unit of measure in this triangle is millimeters, the short side's length will be 50 millimeters. We can use the same property in other situations as well. In this situation, we are being asked for the length of not the short side, nor the hypotenuse, but the length of the medium length side, what I call the long leg of the right triangle. Normally we would find that length using Pythagorean theorem, and I have set up a Pythagorean theorem formula right here. But we can't use Pythagorean theorem if we only know one side. There are 3 variables in Pythagorean theorem, and if we want to solve for a missing side with algebra, we have to be able to replace 2 of those with a value, a number. Well, using this property will allow us to do that. We can see that the hypotenuse is 5 meters in length, so the short side must be equal to 5 divided by 2. The short side is equal to 2.5. Because the unit of measure is meters, the short side is 2.5 meters. Now that I have 2 sides, the hypotenuse and the short side, I can go ahead and use Pythagorean theorem and solve for what was really being asked for, the long leg. The long leg squared, I will name that leg B, is equal to the hypotenuse squared, that's 5 squared, minus the short leg squared, that's 2.5 squared. B squared is therefore equal to 25 minus 6.25. B squared is equal to 18.75. Therefore, B, the length of the long leg, will be equal to the square root of 18.75 which is 4.33, and this decimal continues. I will round it off to the nearest hundredth, and that gives me 4.33. Because the unit of measure was meters, it's 4.33 meters in length. So now we can see that this property, hypotenuse is double the length of the short side, but only in 30, 60, 90 triangles, can help us not only find a hypotenuse or a short side, it can also help us to set up a Pythagorean theorem situation to find the long leg as well.